Time for me does not exist as anything like a line on which you can arrange things. I would say that time is, the expression is emergent. What for me really exists is myself and you and things, the chair I'm sitting on. Those are for me all real, or at least behind them there is something which is real. But I don't think there is any time like a substance, like any fluid or anything like that. If you were to take, as you are doing now, making a film of me, you could cut that up into stills of the movie, and then you could put them together at a certain distance apart to make it just exactly as happens with a movie, so that it runs smoothly and it seems to make sense. And I think time is an illusion which emerges really out of the law that governs the whole universe, which puts things together. I call them nows, puts things together in that way to create that impression that there is an all-powerful thing moving us forward. And there's a sort of a line of timeline or something like that. But I think that's all an illusion ultimately. But you and I are real, don't worry about that. The great Paul Dirac's efforts to unify quantum mechanics and Einstein's theory of relativity. And he had come to the conclusion that there might be something wrong with the most fundamental thing that Einstein is famous for, that there's no definition of simultaneity. This you may have probably heard of the block universe or space-time, in which there's no given simultaneity. You can cut up space-time in all sorts of different ways like that. And Dirac had found evidence within the dynamical structure of Einstein's great theory of gravity that that might be wrong. And he just said one sentence. He said, "This result inclines me to believe that four-dimensional symmetry is not a fundamental feature of the physical world." He said this in an article, published an article in 1958 with this. And I read an article in a newspaper about that, and it made me start thinking about time. And I'd never really seriously thought, what is time, before? And then I realized we would never have the idea that time is passing unless we saw motion, unless we were aware of change. So ever since then, I've been convinced that the primary thing is change, or if you like, even difference, and that what we are feeling of time and that it passes all emerges out of differences, out of the fact that we, in the first place, we experience change. We would never have the idea that there is something that we call time passing if we weren't aware of things changing.
So what's the difference if we move to naming it as change rather than time?
Because it leads you to think about how the universe what law might be governing the universe, the way things, how differences arise within the universe. And at the moment, I'm very interested in how structure arises in the universe. We know that near the Big Bang, the universe was very homogeneous, uniform. There was sort of waves coming backwards and forwards, if you like, but it was all very uniform. And here am I talking to you, pretty ordered and still reasonably competent, can talk moderately good sense. How on earth does that come into existence? What is governing the universe that makes that possible? And this huge change from the conditions near the Big Bang to now, these are fascinating issues, and for me they all come out of asking what is time and saying actually time must be about differences. Say, no, let's only construct our theory with what we can be reasonably confident does exist.
And does this, what is left then of the Einstein sort of space-time continuum?
It emerges, the way I think about it, you could, my hands are almost the same. So I can put my left hand on top of my right hand like that, and then I can, so that's sort of putting it in spatial where it is one on top of each other. And then if it's slightly different, I'll put a certain distance between them. Now, that's not a real thing. That's in my mind to try and make sense of how my left hand can be placed relative to my right and how much difference there is between them. So if I have lots of hands or lots of movies, stills of a movie, I can stack them. I call that horizontal stacking and then vertical stacking. And in all cases, the real thing is my hands, but then I stack them one after another, both this way and that way, using only what is the structure in the hands. And out of that, I can construct space-time. And this is not the way people normally think about it. But when you look at it that way, things are different. And I say we must philosophize about these things differently. So that's the difference there. So in a way, time is an illusion. My hands are not an illusion. But saying that they're stacked like that is something that I've put into it to understand the difference between my left hand and my right hand.
So how would you then understand why we feel like we experience time, the temporal nature of reality?
That is the big problem. How does consciousness come into this? So I start off with the great insight that the geologists had in the late 18th century. They got very interested in studying the Earth, and they discovered what is called deep time. They realized that if they were to understand that the structure that the Earth has now, and by the way, that structure has hardly changed since they started thinking about these things well over 200 years ago, they supposed that the Earth was a physical object that had been changing in accordance with definite laws of nature over a very long period. And this led them to the idea of deep time. And it's all encoded in, you could see that the rocks and the fossils are, in some senses, you could see them as records which you could interpret and say, this is how the past unfolded. And there's a wonderful statement, Lamarck, who had ideas about evolution before Darwin, they turned out to be wrong. But Lamarck has a wonderful sentence. He said, the surface of the Earth is its own historian. It all is encoded in the surface of the Earth. If you look around you here, it really is behind me, is the history of the Earth. A geologist can deduce all sorts of things from that. And I call that a time capsule. Now, I would say that in my mind, there's something like a time capsule like that there's lots of memories, and they're all consistent, really, in a way. There's a wonderful moment at the end of the Midsummer Night's Dream when Hippolyta says, no, it must be real what these lovers went through, because they tell their story and it hangs together. It's a consistent story. And she says, it grows to a thing of great consistency. So this is why I believe I am a person and was that little boy Julian many years ago. And I think actually the experience of me seeing my hands moving and you seeing them is because actually in your brain all at once are quite a lot of images of my hand, and somehow or other when the brain tells us a story, it presents us with a narrative. And I think what is happening is that it has a whole lot of pictures all at once and presents them as movement like that. But it's not, it's really in a whole lot of snapshots there. And the last book that Oliver Sacks wrote, called The River of Consciousness, he talks about the insights that neuroscience is developing. And it does really seem to be that the brain processes information and presents, first of all, several snapshots, and then we see them as movement. So I don't think there is movement out in the world. It's something that the brain, it's a narrative that comes to us through this utter miracle of consciousness. Nobody knows how consciousness works. Anybody who says they do, that's just nonsense to pretend that you know that. So I would say the only evidence for the past, and that there is something that we really could call the past, is the consistency of our records, the consistency of our memory, and the fact that we actually see movement. I think that's all it is. As I move my hand like that, you see my hands both there, and you see the movement. But I suspect that's a narrative that the brain is presenting. So that's my explanation of why time itself is an illusion, and even motion is an illusion. But the fact that I can put my hands like this in different positions, that's not an illusion. That's real. At the moment, actually, I'm with my three collaborators, we think we're making real progress in just within classical physics, understanding why the past is so different from the present and the future. Because this is the great mystery of the growth of entropy, which came with the discovery of the laws of thermodynamics in the 1850s. So all the known laws of nature work equally well in the two directions of time. Then why are all the processes we observe in the universe all going in the same direction? We are all getting older in the same direction, you just like me, and all the stars are. We never meet anyone getting younger. Where does this colossal asymmetry in time come from if it's not in the fundamental laws? So 7 years ago, to make a concession to time, an idea occurred to me, which actually I happen to know about a rather important result discovered in Newton's theory of gravity in 1772. This led me to the idea that the Big Bang, so if we pretend there is a timeline of the universe, by which I mean just each individual now, what it's like the stills of the movie. Suppose you have a long, infinite timeline of the universe. And I would say that the Big Bang is, if you like, in the middle, and we're on one side, and our time is going that way, and then there's another universe, or the other half of the whole timeline, where time is going that way. Now, people who are on that side would find that time is going forward in exactly the same way as we find it on this side. It's all very chaotic at the Big Bang. There's no structure there. So we can't see through the Big Bang to the other side, and they can't see through to us. But that restores the overall symmetry. So the overall symmetry of the whole universe reflects the underlying law, which is symmetric in both ways. But on the two sides, the direction of experienced time is opposite. So that's quite a simple, neat thing. So I call this the Janus point, or Janus point, the Big Bang, of course after the Roman god who looks in two opposite directions of time at once. And first of all to show that this model is based on Newton's theory of gravity, and quite a big challenge is to show that it will also work with Einstein's theory of gravity. Now my collaborators made a first step in that, and they've showed that in some senses there are conditions in which you can go through the Big Bang in general relativity, and not only in the comparable situation in Newton's theory. Then there would be more detailed work to be done, but the real challenge would be to make this quantum mechanical, to unify quantum mechanics with this. And we've got ideas about this, but people have been trying for 60, 70 years to unify quantum mechanics with Einstein's theory of gravity, and they, to be frank, they haven't got terribly far yet, or despite the claims that they might like to make. So that's it there. But one thing we do think is that we concentrate on what we say the shape of the universe in any instant. So if you have a triangle, it has a shape and a size, but I think you'll agree that the shape is much more important than the size, because if I hold up an equilateral triangle in front of your eyes and move it backwards and forwards, the shape doesn't change, but the size does. So you would say there's a question mark over the size, whether it's fundamental. Now, if that triangle is the whole universe, you'd need a ruler outside that triangle to measure its size. But if the universe is everything, that doesn't make sense. So we've developed something we call shape dynamics to describe the whole universe. And we think that it might be possible in that framework to unify quantum mechanics with gravity, with Einstein's theory of gravity, because it's taking away something that shouldn't be there. And in fact, really all of the existing approaches to quantum gravity in some way or other are bringing in an external scale which I don't think should be there, or at least there's a question mark over it, and possibly a big one. So that's our hope, but there's plenty to be getting on with in the meanwhile.